Assalamualaikum warahmatullahi wabarakatuh and very good morning to everyone. We are from Group F from Class 9. Would like to present our case study for code course CHM 260 about high performance liquid chromatography, or well known as HPLC. Next, in this group consists of 4 different members, starting with Miss Arina Khairunisa, followed by Miss Nordiana Ashikin, Mr. Shazwan bin Sharudin, and Mr. Amirul Hakimi bin Darasani. Next, in this case study, there are 3 different objectives involved. The first objective is to determine the retention time of standard caffeine solutions, providing benchmark for further analysis. Next, the second objective is to identify the caffeine peak in a soft drink sample utilizing high-performance liquid chromatography, or well known as HPLC. And the last objective for this case study is to determine the amount of caffeine in the soft drink sample using the response factor method. These objectives were meticulously designed to ensure the accuracy and scientific rigor of our research.
Introduction to HPLC. HPLC is a powerful analytical technique used to separate, identify, and quantify components in a mixture. It is widely applied in chemistry, pharmaceuticals, food science, and environmental analysis. In HPLC, a sample is injected into a liquid stream, which is pumped under high pressure through a column containing a stationary phase. As the components of the sample interact differently with the stationary and mobile phases, they are separated based on their chemical properties such as polarity, size, and charge. There are 5 main components in HPLC. First, solvent reservoirs. The function of solvent reservoir is to store the mobile phase. Next, pump. The pump is to function maintains the high pressure flow. Injector. The function is introduce the sample into the system. The column performs separation using a stationary phase. And lastly, the detector. It identifies and measures the separated components. The advantages of HPLC. It provides a high resolution sensitivity and reproducibility for complex mixture, and it is adaptable for analyzing a wide range of compounds including pharmaceuticals, biomolecules, and contaminants. Lastly, application and variants of HPLC. HPLC is used for drug analysis, food quality control, and environmental monitoring. Common variants include reverse phase HPLC or RP-HPLC for non-polar compounds and ion exchange HPLC for charged molecules.
Next, I will explain the methodology of HPLC. HPLC consists of 7 instruments, which is first mobile phase or solvent. HPLC holds the liquid solvent used as the mobile phase and equipped with filters to remove dust and a degasser to eliminate dissolved gases. Second, pump helps to deliver the mobile phase through the system under high pressure and maintains as a stable flow rate to avoid pulsation. Types of pump including reciprocating, displacement, and pneumatic pumps. Injector introduces the sample into the mobile phase. Options included are manual syringe injections, sampling loops, and automated samplers. Fourth is column, which consists of analytical and guard. Analytical column separates samples components based on their interaction with stationary phases, while guard column protects the analytical column from clogging and extends its lifespan. Next is detectors. Detectors identify and measures components as they elute from the column. Types included UV absorbance, refractive index fluorescence, and mass spectrometric detectors. 6 is waste reservoirs, helps to collect and store excess solvents, mobile phases, and eluted samples after passing through detector. Lastly, data system. Data system records and displays chromatographic data, presenting the result as chromatograms.
Moving on to the results, here we show the graphs for determination of caffeine in Standard, Coke, and Levita.
Calculated results are shown below. To calculate response factor, the formula we use is the peak area of caffeine standard is divided with concentration of caffeine standard. Second, to determine the concentration of caffeine sample, peak area in the caffeine sample is divided with the response factor. The value of the concentration of Coke is 1120.27 ppm and the concentration of the Levita is 1784.32 ppm.
Each peak on chromatogram represents a specific compound with the retention time indicating how long the compound took to travel through the column and the peak area corresponding to its concentration. Therefore, these are the results obtained from the HPLC analysis of caffeine in Standard, Coke, and Levita samples. Firstly, the result of caffeine in Standards has a retention time of 2.482 with a peak area of 6249.48779. Next, the retention time for Coke is 2.481 and the peak area is 7001.12305. Lastly, we have caffeine in Levita with a retention time of 2.479 and a peak area of 11151.10000. Moving on to the discussion, high-performance liquid chromatography (HPLC) was used to quantify caffeine in various samples using a precise analytical technique for separating, identifying, and quantifying compounds in complex mixtures. By comparing their retention times and peak areas, the caffeine concentration in each sample was determined. This process involved injecting the samples into the HPLC systems where they interacted with the stationary and mobile phases. From these results, we can see that caffeine in Standard has a retention time of 2.482 that matches closely with the retention time of Coke, which is 2.481, and Levita 2.479, this confirming the presence of caffeines. Meanwhile, the peak areas varied, indicating different concentration across the samples. The caffeine in Standard 6249.48779 has the smallest peak area among all, and the largest peak belongs to the Levita with 11151.10000. Meanwhile, Coke's is in between with a peak area of 7001.12305.
In conclusion, this study successfully achieved its objective. The retention time of caffeine in the standard solution was determined to be 2.482 minutes, closely matching the retention time observed in the Coke and Levita samples, thereby confirming the presence of caffeine in both beverages. Quantitative analysis revealed that Coke contained 1,120.27 ppm of caffeine, while Levita had higher concentration of 1,784.32 ppm. This finding demonstrates the effectiveness of high-performance liquid chromatography, well known as HPLC, as a precise method for identifying and measuring compounds in complex mixture. We trust that this study not only highlights the capability of HPLC as a reliable analytical tool, but also provided the valuable insight into the caffeine content of a commercial available beverages. I guess that's all from us. Thank you.